Okay, we're doing open book test 2122 part 2, which is really 22. We're going to just kind of review the basic derivative rules. The derivative of a constant is 0, so the derivative of 7 is 0. The derivative of negative 8 is 0. The derivative of 3/4 is 0. The derivative of x is 1. The derivative of x is 1. We know that the derivative of a constant of a coefficient times a number times a function is going to be equal to the coefficient times the derivative of the function and then our exponent rule let's say we had 3x to the 4th, you're going to multiply the exponent times the coefficient and reduce your exponent by 1. That's pretty rough. We're going to multiply the exponent times the coefficient and then reduce the exponent by 1. So we take our exponent 4 times our coefficient 3 and we get 12. Reduce the exponent by 1, 12x to the third. Okay? So the derivative of a constant is 0. The derivative of x is 1. If we have a coefficient times a function, then the derivative is the coefficient times the derivative of the function. The exponent rule is that you multiply the exponent times the coefficient and then reduce the exponent by 1. Okay, so those are the rules of derivatives that we've learned so far. We'll later learn the multiplication rule, division rule, and chain rule. Because what we're really going to learn is order of operations. Okay? So these are the basics of derivatives. And then again, if you think, okay, we got, please excuse my dear Aunt Sally, then we would learn a rule for addition, subtraction. Later we would learn a rule for multiplication. Later we would learn a rule for division. And then we would need to learn a rule for parentheses because we've already learned the exponent rule. Okay? So we've got the constant rule. Derivative of constant is 0. The derivative of x is 1. We have the coefficient rule. We have the exponent rule. And then we could talk about addition and subtraction. We learned that the derivative of a sum or difference is the sum or difference of the derivatives, and we'll use that. So then what we will not have learned so far is how to do the derivative of a product, the derivative of a quotient, and deal with something in parentheses. We'll learn those in another lesson, okay? All right, so number 1, it wants us to find the slope of the tangent line to the graph of the function at the given point. Now what is the derivative going to give us? The equation for the slope. And once we have the equation for the slope, what would we do? Plug in the x of the point into that slope equation, and that would give us the slope at that point. Okay? Now, all it asked for, it was for us to find the slope at that point. We want to find the slope at that point. It didn't ask us to find the equation of the tangent line yet. So we're going to do that using the 2-2 method or these derivative rules we've talked about. Now this is the derivative of a sum or difference. So the derivative of the sum or difference is the sum or difference in the derivatives. So the derivative of a difference is the difference in the derivatives. So we can say that g prime of x is, what is the derivative of x squared? Well, that's really an understood one. So the exponent rule says you multiply the exponent times the coefficient, and that would give us a 2. And then we reduce the exponent by 1, which makes that an x to the first. Understand that? And then over here, the derivative of a constant is 0. So what we have then simplified is g of x is equal to 2x. That is the equation for the slope of the tangent line at any given point. So if we want to find the slope of the tangent line at this point, we plug in the x of that point. We would have g prime of x is equal to 2 times my x of 4, and so we would have 8. So the slope of the tangent to x squared minus 4 at the point 412 is 8. Any questions on number 1? Okay. Number 2, while all that's still on the board, we'll go ahead and do number 2. We want to find the derivative of a difference. To find the derivative of a sum or difference, the answer is the sum or difference of the derivatives. So f prime of t will be, now the derivative of t is 1. The derivative of my variable x is 1. And the coefficient rule says that we would multiply the coefficient times that derivative, right? I'm just showing all my work for right now. And this is an understood one. My exponent rule says that I do what? Exponent times coefficient. And then reduce your exponent by 1, so that'd be a t to the first. So f prime of t would be 3 minus 2t. Okay. If I want the derivative at this point, then I'm going to plug in the x of that point. So it's going to be 3 minus 2 times 2, which is 3 minus 4. Which is -1. And we could write it like this. We could say f prime of 2 is -1. Right here we could say g prime of 4 is 8, right? Right? Any questions on the difference quotient and the basic rules of taking derivatives? Okay. That takes us then to the next page. Question number 4. It says find the derivative of each following the derivative rules. Okay, so we know that the derivative of a constant is 0, so f prime of x is 0. What is that? It's the equation for the slope of the tangent line at any given point. Just so we can talk about it, my original function is a horizontal line, right? F of x is 8. If we take any point on that, the tangent to it would be the same horizontal line, which would have a slope of 0. Okay, so that makes sense to us. Now, on number 2, if we want to find the derivative y prime, the derivative of a sum is the sum of the derivatives. The derivative of a sum is the sum of the derivatives. There's an exponent of 1, and there's a coefficient of 1. So the rule, the exponent rule, we got an exponent, we're going to use an exponent rule. The exponent rule is 2. Exponent times coefficient. And then subtract 1 from the exponent. That would make that a 5. So 6x to the 5th. Here's the coefficient rule. We know that the derivative of x is 1 times the coefficient 2. So we're going to have the derivative y prime is equal to 6x to the 5th plus 2. Again, that is the equation for the slope of the tangent line at any point. Any questions so far? Okay. Number 6. The derivative of a sum is the sum of the derivatives. What rule would we use on the first part? The exponent rule. So multiply the exponent times the coefficient and subtract 1 from the exponent, which would be x to the first. The derivative of x is 1. The coefficient rule says you take the coefficient times the derivative. So 3 times 1 is 3. And the derivative of a constant is 0. So g prime of x simplifies to 10x plus 3. Any questions on number 6? Now, remember, I talked about we have to know how to do everything with every operation. Way back yonder, you learned about decimals. You learned how to add, subtract, multiply, divide decimals. And then we learned about fractions. We had to learn how to do add, subtract, multiply, divide, perform exponents and operations on fractions, and then radicals, and it just kept going. Now we're doing derivatives, and so we have to learn how to perform all of the operations on derivatives. And right now, we know how to find the derivative of an exponent, you know, the exponent rule. And we know that the derivative of a sum or difference is the sum or difference in the derivatives, but that's all we know. We do not know how to find the derivative of a quotient. So we don't know how to deal with that x in the denominator. Since we don't know how to deal with that x in the denominator, we got to get it out of there right now because we don't know how to deal with it. Even if we did, it would be easier to move it anyway. So, how would we move that denominator? We would, but we don't want to multiply by x because that'd put an x over there, right? We don't want to do that. We just want to distribute that division by x, right? So we're going to rewrite the original problem. We're not doing the derivative yet. We're trying to get it in a form that we know how to deal with today. And so we're going to have y is equal to x squared divided x would be x. So that would turn into 3x, right? And then here, x divided x, the x's would go out plus 2. But here you would have 4 divided x, 4 divided x. Well, how do you get that on top? How do you move that up? You change the exponent, right? So the x to the negative 1. Remember when you go up? So that's 4x to the negative 1. The negative on the exponent reciprocates it. So if you reciprocate, you need to put a negative exponent. So this becomes 4x to the negative 1. So we distributed the divided by x, used negative exponential rules of reciprocating, so that now we don't have a quotient situation. what we have is simply a sum or difference, and we know how to deal with that. Okay? So, we're going to now find the derivative. The derivative of x is 1 times the coefficient of 3 is 3. The derivative of a constant is 0. And then we have the exponent rule, which is to take the exponent times the coefficient, negative 4. And then we reduce the exponent by 1, which gives us a negative 2. Now, we don't leave a negative on the exponent, so we're going to have y prime is equal to, when you reciprocate that little negative, reciprocates it to the bottom, we're going to have negative 4 over x squared. You understand how we got the negative 4 over x squared? Okay? Any questions on number 7?
When you have that plus 3 on that 3.
There's a 3. I meant to do that. I decided to put that first, and then I lost my 3. Thank you. So, there's my 3 right here. Let's get it back in there. So we got y prime is equal to negative 4 over x squared plus 3, or we could have said 3 plus that. There we go. Lost that 3 over there. Any questions on number 7? Now, don't forget that we also learned how to find the derivative of sine and cosine. We said that the derivative of sine x is cosine x. We said that the derivative of cosine x is negative sine x. And we haven't learned about the derivative of tangent or cotangent or secant or cosecant. We've only learned those two so far. Okay? So we need to remember that. Now, as we find the derivative, we first identify, notice we're identifying lower operations up to higher. What have I got? I've got the operation subtraction, the derivative of a difference. Sum or difference is the sum or difference in the derivatives. And then we began to look for exponent and multiplication. Okay? So we've separated our terms, basically, and then we're going to find the derivative of each term. Now, the coefficient here is 1. We have an exponent, so we use the exponent rule. You multiply the exponent times the coefficient, and then reduce your exponent by 1, which makes that an x. We have the coefficient rule here. We have negative 1/2 times the derivative of cosine x. You understand that? That's using the coefficient rule. And what is the derivative of cosine x? Negative sine x. So we have negative 1/2 times negative sine x. Now, a negative times a negative is a, so that turns that into a plus 1/2 sine x. Now, those are not like terms, so that's as good as it gets. Okay? Any questions on number 8? All right, number 9. What's the square root rule? That's the alarm for class. That's a good time to be stuck. We don't know a square root rule. We know, please excuse my dear Aunt Sally. Well, is square root one of those things? It is. It's an exponent. It's x to the 1/2 power, right? Square root is the half power. The square root is half power. Cube root is third power. And we know of exponential law, so we need to change it into a form that we're comfortable with. And so we're going to have that minus 3 over the fourth root of x would be x to the 1/4 minus 2 cosine x. Okay? Notice we're putting them in a form that we have rules for. And what we have rules for presently is an exponent rule, addition and subtraction rule, and a coefficient rule. And so we're getting them in that form. And we'll just stop there and go back to that next time. But I didn't want to stop without finishing the answer to that question. All right, we'll pick up there next time. Thanks.